Okay, let's take a look at this practice test number 1. Let me go up to the top here. All right, the ones I highlighted here are the ones you seem to have trouble with. So number 1, you did well. So it's just f of x equals 4x plus 5, and it says what's the value when x is -3. So you simply go in and you plug -3 into the function and you get -7. Number 2, you seem to have a little more trouble with. The expression for the w to the 4th minus 36. So what they're really looking for you to do here is factor this from 2 terms to 4 terms. And anytime you have 2 terms, think of difference of perfect squares. So if both numbers are a perfect square, then it's the square of the first one plus the square root of the second one, and the square root of the second one minus the square root. So w to the 4th is a perfect square. It's w squared. And 36 is a perfect square. It's 6. So you have w raised to the second plus 6, w raised to the second minus 6. So it's handy to remember when you're factoring the difference of perfect squares. Anytime you see 2 terms, check to see if you've got the difference of perfect squares, where this is a perfect square and this is a perfect square. All right, number 3, which is not a function. So a function, every x must map to one and only one y value. So you see this first one, this works 5. Every x maps to only one y. And number 3, you can do the horizontal line test and you go across and it doesn't hit more than one y. Number 4, look, 2, the value x, when x is 2, it maps to 2 different y values, a and b, and you can't have that for that to be a function. Okay, so as 4 gets ruled out. This one's fine, right? It's x, you've got every x equals 1y. All right. Question 4, you seem to have a little trouble with this function. Which type of function? Well, a linear function, always you add or subtract the same amount. So from here to here we added 2, from here to here we added 6, from here to here we added, 18. Right, so it's definitely not a linear function, so that means it's an exponential function. Well, if it's growth, it's increasing. If it's decay, it's decreasing. Well, we're not adding a constant amount, and so it's exponential. And it's not decreasing, it's increasing, so it's exponential growth. So that's number 4. Number 5, you did well on. Let's see how let me go down here a little bit. Number 5, so the easiest way to graph these things is to pick 2 points. So I picked when x is equal to 0, and I just plugged it into this function, and I got y is equal to 8. So I know the point 0, 8 has to be on this graph. So A works, D works, I can rule out B and C right off the bat. Then I noticed, let's check when x is equal to 4. Well, when x is equal to 4, 4 minus 4 is 0. 0 times 6 is 0, so the point 40 must be on my graph. Well, A is the only one that has both 0, 8 and 40. Okay, you seem to do that one pretty well. Number 6 you had a little trouble with. Which expression is equivalent to this? Well, okay, a few minutes ago we were factoring, now we're going to FOIL, right? So we got to take, remember when you FOIL, it's x times this 3x, x times a -3, 2 times 3x, 2 times a -3. So we get, and then we just combined, so we get 3x squared minus 3x plus 6x minus 6, and then I just combined the minus 3x and the 6x. Okay, number 7. You did well on. So this is just plugging in. Remember, it's in terms of months. So 1 year is 12 months. So it's C of 12. And you just plug 12 in for M and get your answer. You did well on number 8. This is just taking this function here and solving for P. So you move everything to one side so you get P, and you did that very, very well. Number 9 was kind of a tricky question. Remember, the mean is the average, the median is the middle value. So the simplest way to think of this one is if I'm adding 45, which is way higher than any of these numbers, I've got to be increasing the average and I've got to be increasing the middle value, right? Because I've added another value. All right, number 10. You seem to do quite well on. Which linear function? Again, it's one where you're constantly adding the same amount. So that would be B. Number 11, you did really well on. That's simply reading the graph where it's increasing the most. You nailed that one. Number 12, again, another modeled linear function. That's where you're adding the same, C, 50 people, as opposed to adding a percentage growth or tripling or eliminates half. So number 13, you had a little trouble with. Which statement is true? So this is another plug. So we plug 0 into our function and see if we get 0. We plug 3 into our function and see if we get 4. That happens to be the one that works. So this is just, when I plug that x value is, do I get that y value? So in the first one, it will be if I plug 0 in here, do I get the does f of x equal 0? It does not. If I plug 4 in here, I get 12 minus 5 is 7. It's not 3. This one, when I plug 3 in here, I get 3 times 3 is 9, minus 5 is 4. Bingo, that's the one that works. This one doesn't work, right? 5 times 3 is 15, minus 5 is 10, not 0. Okay, easy points. Number 14, let's see what we got here. Yeah, you seem to know this one. Okay, so remember the fixed cost or the starting point is $5.75, and then each topping is 75 cents. So for each topping, it's 0.75 plus it's always $5.75. Good job. Number 15, you also did a good job of. So you were able to factor this. So you're good at your AC factoring, right? So good job factoring that. 16, you had a little problem with. These are these exponential relationships. Okay, so I'm looking for anything where I'm not adding a constant amount. So this first one, I'm adding 3, I'm adding 3, I'm adding 3, I'm adding 3, so that's linear. This one, I'm adding 12, then I'm adding, I don't know, a huge amount, another huge amount. So this is exponential, right? So number 3. Here I'm adding 5, adding 5, adding 5, adding 5. Here I'm subtracting 2.5, subtracting 2.5, subtracting 2. So these are all 1, 2, and 4 are all adding or subtracting a constant amount. Number 3 is where I'm not adding the same amount. I'm increasing by percent, and that's why it's an exponential function. Number 17 you had a little trouble with. Remember, m minus 3 squared is m minus 3 times m minus 3, right? You can't just take m squared, and the trick here is students like to just square this first term and square this second term. You got to remember this squared is m minus 3 times m minus 3, so you got to FOIL them. Number 18. You seem to get this one, right? Remember 6-degree polynomial. So there's the 6 degrees, so the leading coefficient is 7, and the constant term is 4, right? The constant term is what's all by itself, and the lead coefficient is what's ever in front of the highest exponent. You seem to nail that one. Good job. 19. Had a little trouble with this one, as I remember. Let's see, what 19? Oh, I didn't give my... Ian throws the ball up in the air. Okay, so if you look at this, when t is equal to 0, like before we start, this first term would be 0 plus 6 times 0 is 0, so plus 0. So we would just have the 3. So when they start, that's the height at which the ball is thrown, right? Because when t is 0, how high is the ball? It's 3 feet high. The maximum height would be at some point higher than when I throw it up in the air. Number of seconds it takes to reach the ground isn't the 3. Number of seconds now. Okay. And then the rest of them you seem to do really well on, right? Didn't seem to have much trouble with the rest of them with the scatter plots. And that's it. Questions, let me know.